Let's now do a few sample size problems. Take a look at problem 1 on page 157. So a survey is being designed at this point by some market research company. So we have a large manufacturer of disk drives and portable computers. The aim is to assess customer satisfaction with the disk drives. As part of the general objective, management wants to measure the average maintenance per year per computer, the average number of malfunctions or breakdowns per year, and the length of the service contract purchased with the new portable computers. Management wants to be 95% confident in the results. So let's go scribble that down. 95% confident means that we're going to use a z-value of 1.96 throughout this problem. Further, the magnitude of the year was not to exceed plus or minus $20 for expenditures. Let's go scribble that down as well. So here's maintenance. I'll just abbreviate that. Maintenance error is equal to plus or minus $20. And then let's see. $1 for malfunctions and 3 months for the service contract. So here's malfunctions, and that was an E of plus or minus 1, and then the contract had an E of plus or minus 3 months. So those were dollars. I think this is months. The research department noted that although some individuals and businesses would spend nothing on maintenance, others might spend as much as $400 in a year. So notice what they're giving us. They're giving us a minimum, 0, and a max of 400. So we can note that. Min is 0, max is 400. Therefore, our estimate of sigma is going to be 400 sixths, which is 66.7-ish. Let's go read on a little bit more. Also, although some portable computers would have no breakdowns, that sounds like a minimum, the maximum would be no worse than 3. So the min is 0, the max is 3, therefore sigma is going to be 3 over 6, or 1/2. Let's see, what else do we have now? Finally, although some portable computers might not be purchased with a service contract, others might be purchased with up to a 36-month contract. So the min is 0, the max is 36, so sigma is going to be 36 divided by 6, which is 6. Part A, how large of a sample would you recommend if each of the 3 variables were considered separately? Well, let's work that over here. N is going to be z squared. So I'm just going to put everything in parentheses at once. So 1.96 times sigma, which is 66.677, whatever, divide by the margin of error, which is 20, and square that. Now, if you do the math, let me go get my sheet. This says you're going to need a sample of about 43. For part B, well, it's going to be 1.96 times the standard deviation, which is 1/2, divided by the acceptable margin of error, which is 1, square the whole lot. You need a sample of 1. On the last one, we have 1.96, and then the standard deviation is 6, divided by the acceptable margin of error, which is 3. And so you're going to need a sample of 16 if you wanted to estimate the third one separately. Part B, what sample size would you recommend overall, given the management thought that the expenditures and repairs were the most important? Well, you want to use a sample of 43. And the reason for that is that if you use 43, you should achieve your margin of error on the maintenance. You only need a sample of one on the malfunction, so you're going to be way over what you need on that. Likewise, you'll be way over on the maintenance contract. Part C. The survey indicated that the average maintenance expenditure is $100 and the sample standard deviation is 60. Find the confidence interval for this. All right, so C, we've done our survey of 43. X bar was what, 100? And the standard deviation was 60. So S is 60. Therefore, our confidence interval is 100 plus or minus 1.96 times the standard error. Well, let's work out the standard error. The standard error is going to be 60 divided by the square root of 43. 43 was our sample size. And that's equal to 9.15. So we can just drop that in, 9.15. Let's go examine the margin of error. So 1.96 times that is going to be plus or minus 17.93. So notice that's a little bit less than 20. So we were after 20. We came in at about 18. The reason for this is that the estimated standard error from the sample is a little bit smaller than what we budgeted for. All right, so we budgeted for 66 point whatever. It turned out it was just 60, and that's why this is a little bit tighter than what we had budgeted for. Okay, that's problem 1.